Hello my friends and welcome again to my video channel. Today we'll start a new project, Icom Ic 751 version A. It's a shortwave transceiver from the, I think from the late 80s or so, early 90s. 100 watt output, all modes, all bands. Receiver has general coverage of the shortwave band. The owner claims some problems. First, the receiver is a little bit distorted with distorted audio in some bands or some modes. Maybe it's a problem with USB, LSB or with the upper and lower bands. We will check it. It's a known problem of this transceiver that the trim caps are sometimes bad, have bad contact and the audio is distorted. The transmit mode also has a problem. CW, SSB, no signal, AM, FM, only 15 watt, but high current drain, 15 amps for 15 watt, a little bit too much amps. So we'll do some checks. The first check is on 28 megahertz. To listen to the receive, we have here a marker. Sounds okay. Let's check the lower sideband. Sounds good. There's only one difference. The pitch in LSB is a little bit low. When I go to upper sideband, the frequency of the pitch is higher. Maybe the BFO needs a realignment, but as it sounds, the BFO itself is okay for this frequency. Low. Let's go down in the band. Oh my god. It is band and then also okay. Let's go down further. Let's check lower sideband. Sounds also good. Let's go down to 10 megahertz. Sorry. It's okay. 7 megahertz now. Oh. In LSB it is bad. Let's go to the USB. Same problem. So we can say 10 megahertz and higher it's okay. 7 megahertz is bad. Upper sideband. Also sounds ugly. Well, that means the receive in the higher bands, 10 megahertz and higher is okay. 7 megahertz and lower is bad. Seems to be a VCO problem. And the pitch USB LSB is also not okay on the higher bands, so we have obviously a problem with the alignment on one side, and on the other hand maybe bad trim caps. What the owner said, that there's a problem. The next check is the output power of the transceiver. The owner claimed that there is no output or low output. I cannot see any problem. We have here full 100 watt or nearly full. In SSB mode, in CW it would be more. I cannot connect my key to it because there's also a keyer inside, and the plug is a 3-wire plug, not a 2-wire plug. So I need a different wiring or an adapter, or I should look for my Iambic keyer to connect it here to the internal keyer, set the speed, and it should operate. But that's not the topic in the moment. We can see we have output power, and we have here current flowing. That's the approximately 10-12 amp in the peak. The compressor is also okay for the microphone. We can reduce it a little bit. And the others are also okay. So I can say the transmit output power is okay. And now we will focus on the topics with the trim caps, which are obviously bad. This transceiver has totally 4 VCOs for the different bands. They have to be set according to the manual to different frequencies. I found an information in the net. The owner gave it to me. And the most common failures, service questions, it's easy to locate. We have 4 trimmers, and obviously the 2 lower trimmers for the 2 lower bands, 7.99 and 14.999 megahertz, make the trouble. C78 and C88, and according to the manual, these are 2 trim caps. And when I go down to the 7 megahertz band, now it sounds okay. But when I touch this trimmer, I only touch it. You hear it. And the next one is on 14 megahertz. It's this one. You can hear it. Let's go to 21 megahertz. It's this one. Mm-hmm. 28 megahertz. The sound is also a little bit crispy, so I think I have to replace all 4 trim caps by new ones. The VCO board is out. We have to remove 6 screws, 2, 4, 6, unplug some connections, here, here, flat cables, and then we can flip it out. This is soldered, no problem. It is long enough, and then we can take off the shield, unsolder it, and look what is underside. We also have to remove this shield, at least the top. I'm not sure whether we have to remove the whole box or only the top, the cover. We will see. Now let's start with the shield on the bottom side. With a desoldering gun and a lot of patience, it's possible to lift the bottom cover and to unsolder it step by step. Of course, We have to be careful not to damage anything. But with this method it is possible. The top cover is connected with a lot of pins to the chassis, to the ground. They also have to be unsoldered. Pin by pin. Now we can try the, oh, there's some wax inside. Yes, I've read it in the forums, there's some wax. But now it should be possible to remove it. Oh no! Wax, wax, everywhere is wax. These are the 4 trim caps we are talking about. Here we have the 4 trim caps, 1, 2, 3 and 4. All 4 trim caps are out. 2 blue and 2 brown ones. The brown ones are the C78 and 88. 78, these are the 10 picofarad trimmers. The 2 brown ones, and the blue ones are the 6 picofarad trim caps for the higher frequency bands. Okay, they're out. We will feed in 4 new ones. The new trim caps arrived. We can solder them in. Small hint, look for the connection which is electrically connected to the alignment slot. This should be grounded, this part. When you use an alignment tool, of course you should use a ceramic or a plastic tool, but sometimes when the trimmers are a little bit hard and stiff, it's necessary to use an alignment tool with a metal blade, at least a metal blade, of course not a complete metal screwdriver. And in such a case it is good when this part, which is electrically connected to the alignment hole or slot, that this part is grounded and not the hot end of the trim cap. So use a continuity tester, and then you can see that this part is grounded. As expected, we see it is fed up to the top of the trimmer, and this is ground, and this should be connected to ground when we feed it in, and the other one is the hot end. The new caps are in, 6 picofarad and 10 picofarad. They have a different color, but it is not a standard code which color is which capacity, so you have to look for the manufacturer's data. 10 pico. And now I will install the shield, but only a provisional installation to see whether we are on the right side and whether we can align the VCOs to the wanted frequency range. A first check shows that the PLL now works. The scope is connected to the test point on a frequency of 7.9999. The voltage should be 6.5 volt. It is 6.5 volt. When we go to 8 megahertz, we have a jump to the next frequency range, which is not okay, not in the range. And now when we go up to 14, is it 14? Yes, 14.999. Again we have 6 volt, 21.999. You see, for lower frequencies we have a lower tuning voltage, again 6 volt, and the Maximum frequency is 29.999. Again 6.5 volt. So I will bring in the board finally, solder all shieldings, make all connections, and then start the alignment of the trim caps. The bottom shield is also in place again, soldered around. All pins are soldered. By the way, a small hint: whenever you see a semiconductor on a heatsink, retighten the screw and the nut. Over the years the screw may get loose, or the grease, there is no thermal grease as I see, but when there's a grease between, it can dry out, and it's a good idea to retighten these screws just to prevent any problems with overheating and so. Okay, we bring back it into the right position and do all connections. The board is in place again. The scope is connected as described in the manual to what is this, R202. The probe is set to 1, and in parallel we have the voltmeter, and now we have to check the tuning voltage and the PLL at the various frequencies. First check is at 8 megahertz. This voltage should be 3 volt. We have 3 dot something. I've realigned it a little bit, and then 7.9999. When we go one step down, tack, it should be 1.5 to 2 volt. We have 155. Okay, that's the lower limit, but it's important, I think, to have not a value below this voltage, so it's important to have 155, and the 2 volt is not so critical. Then we can connect the scope to the next resistor. It's R46. Now it's connected to R46, a little bit difficult to locate it. The voltage should be at 7.99. Do we have 7.99? Yes, we have 7.99. It should be 6.5 volt. 645. This should be adjusted with C78. So this capacitor here, so we can align it now. One of our new capacitors. .5. Okay, when I go to 8 megahertz and above, we have a different tuning voltage, different range. Maybe I should swap the mode. The next frequency is 14.999 megahertz. C88, it is okay. I pre-aligned it a little bit, but it's good now. Next frequency is 21.999. We have 21.9999. It should also be 6.5 volt with C97 with 6.7. Okay, there is some tweaking necessary. .5. And the last one is 29.999. Should be also 6.5. We have 29.999, yes. C107. Also 6.5 volt. Some further checks on R202 again, as we had before. Not only check 8 MHz, we go down to 8 MHz. The voltage should be 3 volt. When we go to 15 MHz, voltage should again be 3 volt, it's okay. And at 22 MHz, we also have 3 volt as specified. That's also okay. Now we connect the cathode of D8 and set the frequency to 7.999. And the voltage should be 2.5 volt. It is. So we can say now the caps, string caps here are all in the right setting, and we can make another check of the, I think the next could be the frequency accuracy in general with the frequency counter, because this alignment also has to be done on this board. We have another error in the manual. Connect the frequency counter to R1 on the R2 side. R1, R2 is this one, but this one is the supply voltage stabilized with the Zener diode. Makes no sense to connect the frequency counter here. The frequency counter should be connected to the output of the 30.72 MHz reference oscillator. I've chosen pin 1 of this IC, and then I can measure here the frequency 30.72 MHz. With a connection point, sorry. Here we have the connection. The integrated circuit is down here. Maybe you see it. And the counter indicates 30.7 MHz, as it should. 7200, 110 kilo, 1 kilohertz, 100. This is 33 Hertz away. I do not align this because I have to open the core. It is sealed with wax. Makes no sense. For 33 Hertz, I leave it as it is. I don't touch it. Another short check of the BFOs. Some hint to the calibrator. Of course, I've set the calibrator to the required 3 volt. This calibrator here is there to adjust the reference oscillator and to realign it when it is a problem with the accuracy. It can be done. This is set to the correct voltage, so I measured it right. Well, the BFO frequencies. When I did the first check, I had the impression that there's a little bit of difference in the pitch and the sound between USB and LSB. Maybe you hear the difference. So I connected the frequency counter to the BFO output. I'm in the mode USB on 14 MHz. And the frequency should be 9.01300, so the 18 Hertz is wrong, not relevant. 18 Hertz. Important is the 0130, and then the rest we can forget. Let's go to LSB. The frequency should be 9.01000. We have 099999. It's also okay. I don't touch it. In CW mode, the frequency should be 0099. It's also okay. All the coils are sealed with wax. When I open it, it will be difficult. Don't touch it. And on RTTY, where's RTTY? Here's RTTY, which would be 00847 00843. We can also forget it. Some hertz. Error of some hertz is okay. Well, frequencies are checked and okay for the BFOs. I will close the case now with the shielding and do the final test of the transmitter part, but we have checked the transmit path, so I think it's okay now, and we can close this project. Now a quick check overall frequencies, whether the VCOs are okay now. I'm in general mode, not ham mode, general, gene. The calibrator switched on, and with every megahertz, we have a new setting of the VCOs, but the calibrator is stable. The amplitude varies a little bit, okay, not so critical. Now let's go to mode USB. Well, the VCOs are okay on all bands and all frequencies. So that's it. Now short check of the transmit function. But I discussed with the owner, he has obviously a problem with the power supply, not with the transceiver. And another hint, all such transceivers have a knob, switch off the monitor, the marker, have a knob to set the strength of the tuning knob. There is a brake, and this brake can be adjusted. Here it is a knob, a hole, and with a screwdriver, a small screwdriver, there's a screw in it, slotted screw. It can be set how strong or how smooth this knob moves. I've set it a little bit smoother. The owner wanted it to have a little bit smoother setting. This is a secret. Not so difficult. Well, now to the transmitter. A short test of the output. 80 meter band. I connected my Icom Ic here. I cannot connect my straight key to it because the connector on the rear side requires a 3-wire connection, not a 2-wire connection. So I have the wrong plug on it. But with the Icom Ic here, we have the keyer. The IC 751 version A has an electronic keyer built in, and we have full output power, 100 watt. I go to a higher band, 7 megahertz, 10, 14, you see here 100 watt, 18, 21, 24.5, a little bit less, 28, okay. The higher band's a little bit less output power, but it is okay. I think for the purpose we can accept it. That's it with CW. Now let's check SSB. The compressor is switched on. I don't need Vox, but let's check Vox. Why doesn't it work? I think I know the problem. When the microphone output is only connected to the output when the PTT is pressed. You see here when I feed in the knob, sorry, the plug, then we have a short moment where we transmit, and then it goes down to receive. So the Vox operates, but when I speak into the microphone, the PTT connector is not connecting the microphone, the capsule, to the input. That's a problem with many mics. So we don't have Vox, but that's not the check in the moment. One, two, three. Okay, we have full output. Let's check it in mode AM. I don't know how many watts, but I think 100 watt, a quarter of 100 watt is typically the carrier for AM, would be 20-25 watts. Now let's go to FM. Ah, 1.9. Let's go to a higher frequency. Well, seems it's also okay. Full output power. You can check the ALC. Okay. Okay. That's it. Now we go to the other functions, play a little bit around with it. But in general now I can say the transceiver is okay. We only had faulty trim caps for the VCOs. When we have such faulty trim caps, there's another solution which can be tried. Simply rotate these caps with a screwdriver and rotate them many times. Add some tuner spray or alcohol or something like this, which evaporates without residues. It could help for some time. When you want to sell it in the net on one of the known platforms, you can do this and can sell it as checked and operating, and the problem will occur hopefully after some years, not earlier. Okay, that's it. That's the end of this project. It was an easy project compared to the battles with the TR7 in the last episodes. It was quite easy, only to swap some trim caps, not more, do a realignment, check some frequencies. That's it. Can go back to the owner. Stay healthy, stay tuned. See you on this channel.